So today we're going to learn about dilations. A dilation means that we are doing some multiplication to either our x value or our y value, and that all depends on where the placement of that multiplication is. So in the first question, it says identify the parent function f of x of the given g of x, and then describe how the graphs are related, and then graph g of x. So the parent function is f of x is equal to x cubed. So that's the function without any transformations attached to it. And then to describe the changes, what's happened is we've had a vertical dilation by 1/4. And a vertical dilation changes our y values. So my triangle is my short form for the word change. It is a delta. So we're going to start by setting up our table of values. And we set up our table of values based on the parent function. So I've put together the table of values for the parent function. -2, when we plug that into our parent function of x cubed, we end up getting -8. Then we're going to apply our transformation, which is that vertical dilation by 1/4. So we have 1/4, and we're going to multiply that 1/4 by the original y values. So we end up getting -2, -1/4, 0, +1/4, and 2. Now we don't have any transformation changing our x's, so we're going to graph our original x's paired with our new y's. So I have my xy coordinate plane, and I'm going to do 0, 0, -1, -1/4, +1, +1/4, then 2, 2, and -2, -2. And then I'm going to join up the points. And this is my new cubic that has a vertical dilation of 1/4. In the next example, we're given g of x. We still have to find the parent function and list all the transformations. So the parent function is our square root. So I'm going to write f of x is the square root of x. And then I'm going to go through and find the transformations. Now before I do that, I actually need the coefficient of x to be 1. So I need to factor what is underneath the radical. So again, I need the coefficient of x to be 1 before I read off the transformations. So it's still underneath the radical, but I'm going to factor out a -2. So I'm left with x minus 3. And then this -2 is still on the outside. Now I can properly read the transformations. So the -2 on the outside means that we have a translation down by 2. And that's going to change the y values because up and down changes y values. The -3 that's on the inside of the parent function is a translation to the right by 3. So remember, it's the opposite sign if it's underneath the radical or inside of the parent function. The negative that's on the inside, this changes our x values. The negative that's on the inside is a reflection in the y-axis. And a reflection in the y-axis, that changes our x's. And then the 2 is, again, on the inside. So that's going to be a horizontal dilation by 1/2. So as a reminder, anything that happens on the inside of a parent function, so this is the inside, it's going to change our x values. And with that translation left and right, if we see a negative, it's actually going to the right by 3. And if we see a 2, it's actually a horizontal dilation of 1/2. So you're taking the reciprocal of that number. So now that we're going to come up with our table of values, so we start with the parent function, so the square root of x in our table of values. So notice that for our table of values, I didn't pick negative numbers, and that's because of it being a radical. You can't take the square root of a negative number. Then I'm going to apply my transformations. So I'm going to apply to the y values, the only one that is changing our y's. So we're going to take the original y and we're going to subtract 2. And our x's, we have more transformations. We have that reflection. We also have the dilation. And then we have to the right by 3. So we add 3. The order of operations matters. So we do our multiplications first and then our adding and subtracting second. So if I take 0 and plug this in, I get 0 plus 3, which is 3. If I take 1 and I plug this in, I have negative 1/2 plus 3, which is 2.5. If I take 4 and plug this in, I have negative 2 plus 3, which is 1. Then I'm going to take my y values and I'm going to subtract 2. So negative 2, negative 1, and 0. Then I'm going to take my new x and my new y column and I'm going to graph. So I plot my points, 3, negative 2, 2.5, and negative 1, and 1, 0. And there is my radical with its transformations. In the last question, we are going to come up with the equation. So we start by looking at our graph and we identify it as our rational. So our parent graph is f of x is equal to 1/x. Now, f of x is equal to 1/x looks like this. It has asymptotes at x is equal to 0 and y is equal to 0, meaning that the graph follows those imaginary lines. Now look at what's happened with our asymptotes. The one that was originally at y is equal to 0 has been shifted down by 5. So that's one of our transformations. We have a translation down 5. And the asymptote that was originally at x is equal to 0 has been shifted to the left by 2. So, and left by 2. So we start by identifying the parent function and identifying the translations. The next thing that we're going to do is we're going to sub in a coordinate. And why we do that is to identify our our dilation. So I paused for a second just to write some notes for you guys. So after you identify your translations, because those we can read off of the changes of the asymptotes, we're going to sub what we know into a generalized equation, and then we're going to solve for our dilations. We're going to assume that they are vertical dilations just because at this point we don't know if they're vertical or horizontal. So my new equation is g of x. That's the one with the transformations. We don't know what the vertical dilation is, so I'm going to put an a there. And then we have x plus 2 to indicate that translation to the left 2, and then down 5. So I'm going to plug in a coordinate, -1, -2, for x and y. And that's how we're going to solve for a. So -2 is equal to a over -1 plus 2 minus 5. I'm going to add 5 to both sides. So we end up getting 3 is equal to a over -1 plus 2 is 1. So a is equal to 3. Now that we've solved for a is equal to 3, we can put that back into our equation. So g of x is equal to 3 over x plus 2 minus 5. And that's our final equation.